Hello, good morning everyone. My name is Aryan. I am a student of Bangalore Institute of Technology. I am going to present the topic the digital electronics in digital electronics. The topic is pipelining. Pipelining is basically a Pipelining is basically a way of dividing the larger task into a smaller subtask. And in this presentation, we are going to explore the topics what pipelining is, how it is work, and the benefits it bring to the digital circuit in the world of digital electronics, and the challenges which the engineer faces and how they overcome them in the real world, and its application in the real world and its future potential in the world of digital electronics. Pipelining is a powerful technique in digital electronics that allow for more efficient processing. By dividing tasks into smaller stages, we can achieve higher throughput and better resource utilization of the digital circuit or in a digital products. This presentation will explore the art of pipelining and its impact on a digital circuit in a real world. What is pipelining? Pipelining is the process of breaking down a task into smaller, manageable stages that can be executed concurrently with each other. Each stage completes the parts of a task, allowing for the multiple instructions to be processed simultaneously. This leads to a significant increase in the performance of a digital circuit. Pipelining is a method used in digital electronics to enhance the performance by dividing a task into smaller stages that work concurrently. Let us give an example of the pipelining in a real world. Imagine a car manufacturing line where one team assemble the chassis and while another install the engines of a car and yet another applies the paint in that car. Each team operates simultaneously on a different work at a time, increasing their overall productivity, enhancing the complexity of a car to manage and handle them in efficient way. Why pipelining matters. Implementing pipelining can lead to enhance the throughputs, reduce latencies, and improved overall performance in digital systems in a digital electronics products. It enables circuit to handle more operation in a given time, making it essential for a modern microprocessor and FPGA systems. Pipelining enables higher throughput by overlapping the task. It's no longer about one step at a time, but multiple steps moving in a harmony or simultaneously at a time. Without implementing pipelining, digital systems handle tasks sequentially, leading to delays and underutilized resources in the products. Major impacts is pipelining enhance the throughputs, reduce latencies, etc. A typical pipeline consists of several stages like fetch, decode, execute, write back. Each stage performs a specific function, allowing the next instruction to begin processing before the previous one has completed, thus optimizing the use of resources. And the fetch instruction. In fetch, the instructions are fetched from the memory, and another one is decode. Decode instructions are interpreted to understand the task and execute. The execute operations like calculation and logics are performed in this way, and the another one is write back. The result are stored for the further uses and visualization. Challenges in pipeline. While pipelining offers many advantages, it also presents challenges such as data hazards, control hazards, structural hazards. Understanding these issues is crucial for designing efficient pipelines that minimize the stalls and maximize the performance of a digital circuits. And there are a few challenges or problems in pipelining, such as data hazards, control hazards, and structural hazards. Data hazards occur Data hazards occur when the instruction depends on the result of previous instruction. Techniques such as data forwarding and stalling are employed to mitigate these hazards, ensuring smooth operation within the pipelines. And these occur when the instruction depends on the result from the earlier stages. For example, if one stage needs the data not yet computed by another state, there is a delay in the process. The solution to this problem is techniques like data forwarding and stalling help to manage this problem in an efficient way, and a very utilized way of using the products. And another one is control hazards. Control hazards arises from a branch instruction that alter the flow of execution from the previous one. Techniques like branch prediction and delayed branching are used to minimize the impacts of these hazards on a pipeline performance. Control hazards basically is a branch instruction can disrupt the flow by changing the execution path of a previous instruction. For example, the conditional jumps create uncertainty in what to process next is doing. Solution to these problems is branch prediction techniques anticipates the outcome to reduce the disruption in an efficient way to reduce the complexity of a process. And the another one is structural hazards. Structural hazards occur when the hardware resources are insufficient to support all the active pipelines stages. Structural hazards can be occur with the limited hardware can create resources conflicts. For instances, if two stages need the same memory resources, there is a delay occur. To remove this problem, efficient resource allocation and a design can help alleviate these issues, ensuring that each stage has the necessary component to function smoothly on a different process. Solution to these hazards is efficient design and resource allocation are key to solve this problem in an efficient way. Applications of pipelining. Pipelining is widely used in various applications, including microprocessor, graphics processing unit, GPUs, and a digital signal processor, DSP. Its ability to enhance performance make it a crucial technique in a modern electronic design in a in a present way or a future way. A microprocessor leverage pipelining to handle the multiple instructions simultaneously, ensuring smooth and fast operation within the system. GPU process graphics tasks efficiently using the pipelines for rendering and image processing. DSP utilizes the pipelining to manage the audio and video signals in a real time. Visuals are the display examples like an Intel processor architecture diagram or a GPU rendering pipeline is important to us. Future of pipelining. As technology evolves, the need for the efficient pipelining techniques continues to grow. Innovation in a quantum computing and AI may lead to a new methodology that enhance the art of pipelining in a digital electronics. Pushing the boundaries of digital electronics, digital electronics in AI system, the digital efficient pipelines allows for a faster neural work and network training and interferences. As technology advances, the quantum computing might redefine the pipelining by enable a new methodology. Closing throughput is the future of pipelining lies in the innovation. As new challenges drive the creation of a better solution for the society. Best practices in a pipelining. To optimize the pipelining, designers should focus on minimizing the hazards, balancing the stage, and ensuring effective resources utilization. To design effective pipelines, engineers must focus on minimizing hazards, balancing workloads across the stages, and ensuring efficient use of resources. Continuous revaluation and testing are essential to maintain a high performance and efficiency in digital circuits. Interactive elements, interactive elements where the pipelining might be beneficial outside the electronics to ensure the process process uses the resource utilization effectively in a efficient way. At last, the topic is conclusion. Embracing the pipelining. In conclusion, pipelining is an essential techniques in digital electronics that enhances performance and efficiency. By understanding its principle and challenges, designers can create innovative circuit that meets the demand of a modern technology in a real world. Pipelining is a transformative techniques that enhances the performance and efficiency in a digital electronics and reduces the complexity of a digital circuit. By understanding its principle, overcoming its challenges, and innovative its application, we can continue pushing the boundaries of technology. And pipelining is not just about technical efficiency; it's about creating harmony in complexity and reduces the complexity faced by the programmer in designing the digital circuits